Welcome to Fundamental Neuroscience for Neuroimaging. Since the invention of this methodology, the number of studies using this technique have grown exponentially from only a few studies reporting on this method in the early 90s to over 16,000 publications using magnetic resonance imaging methods in the year 2014 alone. Studies using MRI initially consisted of only a few data points, with the initial study in 1977 using only 106 individual data points. But this too has grown exponentially, with recent studies reporting over 10 billion data points in a single MRI study. This scale is even greater when we consider multi-site studies like the Alzheimer's Disease Neuroimaging Initiative, which includes thousands of subjects at multiple sites who each complete multiple visits over time. In that sense, the analysis of modern neuroimaging data is a true big data problem. The goal of the current course is to provide an overview of neuroscience topics relevant to the understanding, analysis, collection, and interpretation of neuroimaging data. So what is neuroscience? Neuroscience is the multidisciplinary study of the biological basis of behavior. It includes many disciplines, including neuroanatomy, where neuroanatomists focus on delineating the structures of the human brain, neurochemistry, where chemists look at the chemical properties of communication in the brain, neurophysiology, where people study the electrical properties of the brain, and neuropsychology, where people try to elucidate the cognitive domains and the structures that support those cognitive domains in neuroscience. But it also has many different branches of neuroscience, including molecular neuroscience, cognitive neuroscience, clinical neuroscience, computational neuroscience, developmental neuroscience, and cultural neuroscience, to name just a few. Neuroimaging is a collection of methods to image the structural, functional, and chemical properties of the central nervous system. It is a method that is employed by many disciplines and in many branches of neuroscience. In this course, we will cover a number of course topics to help us understand neuroimaging data, which will include the structural and functional organization of the brain, terminology of brain organization, brain networks and communication in the brain, cognition and cognitive domains, the principles of magnetic resonance imaging, neuroimaging methods broadly, and experimental design and neuroimaging studies.